Hey everyone, this is Paul and welcome to this video where I'm going to explain why you should learn logical thinking. Now, hopefully you already see the value in learning to think logically and systematically, and as you follow along with the course, you'll be able to see the application. But if not, in this video, I'm going to try to motivate why you should learn and why you should care and why you should pay attention. So what if I told you there was something you could do that would help you avoid BS, create more convincing arguments, write computer programs that are provably correct, design more efficient circuits, write better proofs in math, improve your thinking and writing, and design better experiments to do better research? Well, you may not be interested in all of these, but if any of these sound useful to you, then I think you've come to the right place, because being able to think logically has been empirically linked to each of these topics. And throughout this course, what I'm going to be doing is discussing the basics of arguments, digital logic based on transistors, set theory, and more. So I can pretty much guarantee that if you learn these fundamentals, you will become better in these areas, and this is particularly useful, or particularly the case if you decide to go into a math-heavy field like computer science or electrical engineering, because logical thinking is going to form the foundation of mathematical reasoning, and it'll help you become more discerning and clear. Now, why would this be the case? Well, to avoid BS, say, let's go through each of these. Well, this means you know how to tell if a claim is supported by evidence or reason. So what we're going to be doing is analyzing arguments to see whether certain conclusions are supported by premises, supported by the evidence in question. This is the same basically as creating more convincing arguments. I'll show you how to create logically airtight arguments using just a few simple rules where the conclusion basically logically follows from the premises. These are airtight. It'll be just like pushing over dominoes. When it comes to computer programs, I'll be showing you how to use truth tables and Boolean algebra to analyze and verify your programs to ensure that you get the output or result that you want. When it comes to mathematical proofs, I'll be taking you through some of the simple techniques you can use and why pretty much all proofs in math follow kind of the same simple patterns that are related to the argumentative structure we're going to outline by the axioms of logic. More on this later. Also, here in this case, we're going to be talking about quantification and set theory, and this is where I find many students struggle, especially when they get to their upper level math classes. So a lot of times people are fine kind of not knowing that much logic when they get through high school and even some college math, but maybe they hit real analysis, they hit linear algebra, and this is when it starts to become really important that they understand these more abstract logical concepts that we're going to be talking about. When it comes to circuits, what we do is we build hardware to do specific tasks out of simple building blocks like transistors. I'll show you how to combine transistors in a way where you can build hardware to do the functions you have in mind. So you have an idea, I want to implement this in hardware, I'll show you how you can do that. We'll be building these simple gates and then chaining them together to do more complex tasks. But when designing circuitry, it's a little different because we first have a goal we want to get to or a function we want to implement, and then we're going to go through building this function out of these individual components that follow a certain set of rules. And believe it or not, this is actually related to all the work we're going to be doing in logical argumentation, and I want to be very, very explicit about this link. And when it comes to improving your thinking and writing, you'll be more clear and be able to anticipate objections by spelling out your thesis or your arguments as a set of points which are supported by multiple strands of evidence. This will also help you design experiments where you can test the different claims you want to make and find out how to design experiments that really get at the heart of the matter, which is super helpful if you're, say, debugging things, if you're writing software, or just to get to the bottom of a research question or the bottom of a disagreement with someone. So what we're going to do is begin by talking about the basics of arguments and their logical structure. And while we do this, I'll be making the connection between logical arguments and digital circuit design via connectives and implications. We'll also talk about common mistakes or pitfalls that people make in their thinking which can lead to incorrect results. Some of these are fallacies. There are formal fallacies and informal ones. We'll be talking about both. And then we'll talk about sequential logic, which forms the backbone of computers, including most programming software and digital design. We'll then go into set theory, which involves reasoning about collections of things and show how this is sort of related to discrete mathematics that's used and necessary to design many software applications. And this, you see this all the time in, say, database system and modern high-level programming languages. And then we'll talk about different proof techniques in mathematics, how these follow from the basics of logic, because this material is super, super foundational for mathematics as well. And I like to think of logic, and in particular mathematical logic or analytic logic, as the glue or connective tissue between mathematics, philosophy, computer science, and electrical engineering, with of course plenty of applications in law and other disciplines of science as well, even theology. There's lots to learn. I'm going to do my best to break it down and present it as simple and as broad as possible so that you can become a better thinker. Thanks for joining me, and I'll see you in the next video where we'll begin by talking about propositions.